Dear students, myself Dr. Yachna Tyagi, Assistant Professor Physics from Government PG College, Noida. So students, today we are going to have a lecture on kinetic theory of gases. So first, let me share my screen. Okay, here we go. So for the kinetic theory of the gases, first of all, we should learn what is an ideal gas. An ideal gas is one which obeys all the gaseous laws like Joul's law, Boyle's law, Avogadro law, and with that, this is always going to remain in gaseous state at all the temperature and pressure. Means the ideal gas is maintaining its gaseous state at all the temperature and pressure, right? The second point is the molecule of the ideal gas. They do not exert force of attraction and repulsion on one another. Means they are having only kinetic energy, right? The molecules of the ideal gas, they do not exert force of attraction. They do not have any kind of attraction and repulsion forces in between them. The gas equation, if you know from your previous studies, is given as PV equals to RT, where what is P? P is the pressure, V is the volume, R is the gas constant, and T is the temperature at the absolute scale, right? This is termed your ideal gas. Ideal gas में students उसकी जो मॉलिक्यूल्स हैं उनके बीच में कोई भी फोर्स ऑफ अट्रैक्शन और रिपल्शन नहीं है इसीलिए अगर हम आइडियल गैस की बात करें देन दिस कैन नॉट बी लिक्विफाइड राइट ओके and as you know, if we are talking about the gaseous state of the matter, the molecules are very much farther apart from each other and the cohesive force of attraction between the molecules is negligible. बहुत ही कम है अगर आइडियल की बात करेंगे तो आइडियल में जीरो है राइट Ideal में force of attraction या repulsion between the molecules is zero. But if we talk about the real gases, that will be also negligible, right? That's why they are free to move in the entire space available to them. Okay? The fundamental concept of kinetic theory of gases, that is the existence of molecules in random motion, this can explain several properties of three states of matter like expansion, change of state, melting point, boiling point, cooling due to evaporation. These are the properties that can be explained on the basis of the kinetic theory of gases, right? And this theory was proposed by Bernoulli in 1783. And later, this was extended by many scientists like Clausius, Maxwell, Boltzmann, van der Waals, and Jeans, etc. Students, this theory is based on some assumptions. First of all, we should learn about these assumptions and then we could understand all these phenomena, right? Okay, so the first assumption of the kinetic theory says that all the gases are made up of small particles and they are termed as molecules. The molecules of the gas are identical to each other and are perfectly rigid and elastic sphere. One thing you should notice over here is when we are talking about that the molecules of the gas are identical to each other, we are saying about one gas, right? Okay, if we are talking about a single gas, then its molecules, all the molecules are perfectly same. They all are exactly alike. लेकिन अगर आप दो गैसेस ले लेते हो फॉर एग्जाम्पल अगर मैं ले लूं कि एक गैस मेरे पास ऑक्सीजन है एंड द सेकेंड गैस इज नाइट्रोजन then the molecules of the oxygen are different from the molecules are of nitrogen. They will be having different size, and shape. Okay, right. Second point, due to this kinetic theory, we are assuming that all the molecules are continuously moving. They are in a state of continuous motion. In what direction? In every direction, in all the direction. With what velocities? With all possible velocities, right? During this motion, molecules collide with each other. This is our third assumption, that when these this gas is kept in a vessel, then the molecules, they are, due to continuous motion, they are going to collide with each other, and also they are going to collide with the walls of the containers. Isn't it? Why they are colliding? Because they are in a continuous, they are in a state of continuous motion. Okay. So when they are having the collision, there will be a change in velocities at each collision. However, this is not going to affect the molecular density. You may think when they are going to collide with each other, they are going to break in number of molecules. No, this is not going to happen. That's why the density, molecular density of the gas is not going to be affected. Okay. Fourth point, fourth assumption says the collision are perfectly elastic and there are no force of attraction and repulsion between the molecules. मॉलिक्यूल्स के बीच में ना तो किसी भी तरीके का अट्रैक्शन है और ना ही किसी भी तरीके का रिपल्शन है. इसका मतलब the energy, the type of energy will be totally kinetic in nature, right? The energy involved over here will be only kinetic energy. The fifth point is the duration of this collision is negligibly small in comparison to the time spent by a molecule between the collision. इसका मतलब ये है बच्चों कि अगर जिस समय पर जो मॉलिक्यूल्स हैं दे आर गोइंग टू कोलाइड, so what is the time of interaction? That time of interaction is very small in comparison to the time spent by a molecule between the collision. एक collision हुआ, उसके बाद दूसरा collision हुआ, उसमें जो time लगा that is quite greater than the time of interaction when they are going to collide with each other. Okay. Last point, sixth point is between any two collisions. दो collisions के बीच में the molecules they move in straight line. Why they move in a straight line? They are moving in the straight line because they do not exert any kind of force of traction and repulsion. So they will move in the straight line with uniform velocity, right? The change in velocity occur only at the collision. But in between the two collisions, they are going to move with uniform velocity and they are going to move in straight line, right? And this distance between the two collisions is termed as the free path. This is called the free path. And its average value, if we are going to have the average of so many free paths, that will be termed as the mean free path, right? These are the assumptions of the kinetic theory of gases, right? And on this basis, we can explain so many properties that I have told you earlier, that you can explain the expansion, change of state, melting point, boiling point, cooling due to evaporation. The pressure of the gases can be calculated and all the gaseous laws can be derived from this kinetic theory of gases. So this was all about for today's lecture. Thank you.